So this is the last graph that we did, finding average rate of change, and the base for this graph, this log function, is 2. Let's see what happens if we increase the base of the log function. So we're going to find the average rate of change for this log function, and this is y equals log of x, and we know if there's nothing listed next to the log that the base is 10. Plus, we can all see that the x values are 10 raised to a power. So that also shows you that the base is 10. We want to find the average rate of change of f of x from x equals 10 to 100. Right? So here we have the point 10, 1, 100, the point 100, or when x equals 100, it's 102. And you might be wondering where those values come from, just as a reminder. Right? So if x is 10, then that would be log of 10. So y equals log of 10. And that just means that what power do you have to raise 10 to get 10? Right? Well, then y would be 1, right? Because 10 to the first power is 10. And then if x is 100, then y equals log of 100. That's saying 10 to what power is 100, right? And that means y would have to be 2, right? Because we know 10 squared is 100. So let's find the average rate of change of f of x from x equals 10 to 100. Right? So we have average rate of change equals f of x2 minus f of x1 over x2 minus x1. Right, so that would be, we'll start with the larger point. So that would be 2 minus 1 over 100 minus 10. Right, so that would be 1 over 90. Right, so you see that the rate of change decreases. Right, so that's a really small slope. One vertical change for 90 change in the horizontal, and it will get worse over time. So the rate of change decreases as the base of the log function increases. And this will grow slower and slower as x gets larger and larger, right? Because for y to get to 3, x is going to have to go all the way to 1,000, right? But then the slope gets really steep as we get close to that vertical asymptote. Let's look at one more. All right, so find the average rate of change from the graph of a nonlinear function. Right, so here we have a trig function. I hope you can figure out which one it is. When you look at the whole thing together, it can be a little confusing. But if you just looked at the part that's in red, right? So if we look at the points here, we have the point 0, 3, and then pi, negative 3, and then 2 pi's back to 3. All right, so who starts at the maximum? That's cosine. Right? It's taking, the period is still 2 pi, right? Because it took 2 pi to get back to 3 again. The amplitude equals 3, right? Because the minimum point is negative 3 and the maximum is 3. And so this is the equation of y equals 3 times cosine x. Right, so we want to find the average rate of change of f of x from x equals 0 to x equals pi. Right, so there we have the point 0, 3, and we have the point pi, negative 3. Right, so I'll mark it down here as well. 0, 3, right, and then you can be x2 and y2, and then pi, negative 3. And you can be x1 and y1. All right, so average rate of change, difference in the x values, minus over the difference, difference in the value of the function over the difference in the x values. Right, so we have then, so the value of the function is the same as y. Right, so we have now 3 minus a negative 3 over 0 minus pi. So 3 minus a negative 3 is 6. And 0 minus pi is negative pi. You can put the negative anywhere you like. I think I'll just put it in front. So the average rate of change is negative 6 over pi. And if you wanted that to not have pi, well, then you can divide negative 6 by pi and you'd get a decimal approximation. But the exact answer would be negative 6 divided by pi. All right, so now let's find average rate of change between x equals 0, which we know is 0, 3, and x equals 2 pi, which is 2 pi 3. And we'll keep u x2, y2, and u be x1, y1. So average rate of change would be difference in the value of the function over the difference in the x values. So that would be 3 minus 3 over 0 minus 2 pi. Well, 3 minus 3 is 0, right? It doesn't matter what's in the denominator. This is still going to be 0, right? So, and if we look, we're literally just connecting those 2 points. That would be a horizontal line, right? The first one we did was this one, and you see that one is not a horizontal line, right? But the second one was a horizontal line. All right, so now let's do the last one. All right, so find the average rate of change. All right, so that is the difference in the x value, the difference in the value of the function. I've done too much distance formula with geometry. So the difference in the value of the function divided by the difference in the x values. All right, so pi halves is right there, pi halves 0. All right, so you be x2, you be y2, and then 4 pi, this is 4 pi 3. Right, function y, that's back up again to 3. So this would be 4 pi 3, right, and you be x1 and you be y1. So this will be 0 minus 3 over pi halves minus 4 pi. All right, so 0 minus 3 is negative 3. All right, so 4 pi is the same as 8 pi halves. So pi halves minus 8 pi halves is negative 7 pi halves. And now let's simplify that. I guess I'll just move these ones over just a bit. All right, so that's the same as negative 3 times, so if you're dividing by a fraction, it's the same as multiplying by the reciprocal. So times 2 over 7 pi. Right? And then that would be, where can I squeeze that in? All right, let's just move it down a little bit further. That would just be, both of these are negative, that would be positive 6 over 7 pi. And there we go, 6 over 7 pi. So that is just, should have done this one in black, I guess. Here, I'll do that one in black so it matches the color I wrote in. There we go. And so this is the line, the slope of the line connecting pi halves 0 with, that's not a very good line, but 4 pi 3. All right, so that's the end of this part of the lesson. All right, and so in the next part we'll look at finding average rate of change, but this time no graph. We'll be working with equations. Thanks for watching. Bye for now.